Hello everybody, here we go. We're going to look at this lovely problems here. It's starting with a U try, which seems mean, but it's not because you already know it. So we're going to use left and right hand sums to approximate these values. To have less stress on everyone, let's just label what these points are. This is 1, 1. This is the point 2, 1.5, 1.4. This is 3, 1.7, and this is 4, 2. That way we don't have to fight about what they are. So you'll go through, find a left hand, right hand. Now you can see that we're going from 1 to 4, and that I'm going to be creating 3 towers. So you'll do a left hand starting at the leftmost side, and the right hand starting at the rightmost side. And go through, and it's going to be real easy peasy, okay? Now, the midpoint rule, when I'm looking here, if I'm using the same, I'm expecting you can do these, left hand, right hand, I'll give you the answers if you're not sure. When I'm looking at a midpoint, midpoint means halfway. So, if I'm still using the delta t of 1, here's the midpoint at 1.5, 2.5, and 3.5. I'm going to have the 3 towers. So now instead of starting at the left end or the right end of the tower, I now have that tower right there. So let's fight about this. I'm going to say 1.5, 1.3, just so we all agree. 1.6. And 1.9. So 3.5, 1.9. So what stresses people out on these is that they think, okay, I'm working with the midpoint, that changes my delta t. My delta t is the length of these towers. My delta t is still 1, okay? It's just where am I getting the y value from? I'm getting it from the midpoint. So I'm still going to say delta t, but now it's going to be of f of 1.5 plus f of 2.5 plus f of 3.5. So for us, that's 1.3 plus 1.6 plus 1.9 times 1. 1.3 plus. And we've got a total of 4.8. All right, so then the trapezoid. Now, trapezoids look like this shape right here. So we can see the trapezoid formula says 1/2 times the height times the sum of the bases, where the base comes from the left side and the right side. And you can see the great thing about the trapezoid is that there is so much less extra space in there, okay? That's the beauty of it. So you can go ahead and do the trapezoid for each one of these. It would be the height is this piece right here. So that's our delta t of 1. And then find these y values. So let me write that out for you. That would be the first tower, then the second tower, then the third tower, okay, and that adding that up will make the trapezoidal rule sum. What you might also notice is that I used the 1.4 twice and I used the 1.7 twice. Ways you can look at that. You can say 1/2 times and then do 2 times all of the middle terms and the endpoints. You can also notice this was the left-hand sum. This was the right-hand sum. So you can do those 2 sums and average them. All right, here we go. Nice little table set up for us. So let n equal 6. What is delta t? So they told me from 0 to 6, so 6 minus 0, b minus a, is 1 again. So the left-hand sum will be 1 times 3 plus 4 plus 5 plus 4 plus 7 plus 8. The right-hand sum will be 1 times 4 plus 5 plus 4 plus 7 plus 8 plus 11. The trapezoid, multiple ways to deal with this, so I can say 3 plus 4 plus 5 plus 4 plus 7 plus 8 is 31. This is 39. If I do the average of those, I'm going to end up with 35. So let's look at it. If we're going to do the trapezoid here, so 1/2 times base of 1, and then 3 plus 4 is the first trapezoid. 1/2 times 1 times 4 plus 5, and then 1/2 times 1 times 5 plus 4. And I'm just using the different y values as my different bases. 4 plus 7. So if I go through, here we go, add that up, or you can look at it and do the left hand and the right hand. So when I add all that up, that's 35, and so was the sum of the left and the right. So either way you want to do it, works for me. Now the midpoint's the last one here. Now I'm changing the n value just so I can have the data to work with. So 6 minus 0 over 3 now means that delta t is now 2, okay? So when I look at each of these, instead of having the 6 towers, we're only going to have 3. So going through 0 to 2, 2 to 4, 4 to 6. Those are my intervals. The midpoint is at 1. The midpoint is at 3. The midpoint is at 5. So we're going to say 2, because that's still the length of it now, times the 4 plus, well, another 4 plus an 8. And that is 32. Now you may be saying that's not the same as the 35 we've gotten. We used a different delta t, so that affects what it looks like. You're going to try this one. We'll go over the answers next time. All right, we're going to look at this real life situation here. Reading through, talking about the fact that it's concave down is nice. We are looking at the balloon, its radius, and the rate that that radius is changing. So they want us to use trapezoids, use 5 subintervals. That works. 1, 2, 1, 2, 3, 1, 2, 3, 4, 5. That would work out perfectly. We would be comparing these two, these two, these two, these two, these two, or a left and a right and average. If we want to do correct units, explain the meaning of the integral from 0 to 12. So if I'm looking at the antiderivative, the derivative here, that's the amount, the radius is changed, the radius of the balloon is changing from t equals 0 to t equals 12. All right, at the bottom here, we're going to look at, we have a couple things here. They want to know, are these sums over estimates? So starting with, if a function is increasing, okay, so here's my increasing function. If I have, starting a left-hand sum, that's going to be an underestimate. Where if I'm increasing and I'm doing the right-hand sum, that's an overestimate. You could guess that these are going to be the opposite. Okay, now midpoint and trapezoid dealing with concavity. So if I start, here is a concave up situation. Midpoint of the 3 points here is going to be that bottom part. So that's going to be an under approximation. Now if I'm dealing with the same thing and I'm dealing with trapezoid, that is going to be an over approximation. And then of course, if I'm dealing with the opposite here, concave down, there's my midpoint. That's an over approximation, and the trapezoid is the under. Have a super duper night.